Okay, so on here, I set your notes handout up a little bit different. I'm not necessarily going in the same order, but at the top I tried to put all the important formulas that we're going to use. So the first one on here is your pH. You've seen pH in your science classes, I hope, right? Sounds familiar? And that is actually calculated by using a logarithm. So pH is the opposite of the log of H3O plus, or the hydronium ion concentration. On pH, we typically round to 1 decimal place, but you could have more. It's just not how you usually see it. So if I said to find the pH of a solution with H3O plus equal to 2.5 times 10 to the negative 4, right? All we're doing is putting it into the formula. I would never expect you to memorize the formula or anything, you just have to be able to use them. So we're just doing the opposite of the log of 2.5 times 10 to the negative 4. All right, so everybody put that in your calculator. And what do we get for our pH? 3.6. All right, part B, find the hydronium ion concentration of a solution with a pH of 7.1. So we have this formula. This time I gave you the pH, so 7.1 is the opposite of the log H3O plus. So we are just solving this log equation. This entire expression just represents a variable. I have to get it by itself. So what would I do with the negative out in front? Divide it over. If the base isn't written, what do we assume it is? So then if you wrote this in exponential form, it would be 10 to the negative 7.1 power equals your H3O plus. If you type that into the calculator, 10 to the negative 7.1 power, you get 7.9. You can do more decimal places if you wanted. But you notice at the end it says E negative 8. That means times 10 to the negative 8 power. So these two examples were just manipulating that log, or that pH formula. Are there any questions on those? If we go back up to the top, the next formula, exponential growth and decay. This one is y equals y sub 0 e to the kt power. K is a constant. If it's greater than 0, you are going to see growth. If it's less than 0, you are going to see decay. Y here represents ending amount. Your y sub 0 is your beginning amount. And t is the time that's passed. E is just that button on our calculator, and K is some sort of constant. All right, so let's look at one. If 800 grams of a radioactive substance are present initially, and 2.5 years later only 400 grams remain, how much of the substance will be present after 4 years? Okay. We have to do a couple different things on this. That's the formula we need, but we have to figure out what our constant is. So to find that constant, we are going to have to use the other information given. Now, we do know something already. What is my y sub 0, my beginning amount? So that's 800. So I have my y sub 0, now we have to figure out k. To do that, we're going to use this other information. In 2.5 years, 400 grams remain. So what's my y, my amount? I don't know k, that's what I'm trying to find, and my time is 2.5. If you divide that 800, it gives us 1/2. This is sometimes called the half-life of a substance, how long until you have half of what you started with. How would I solve for k here? Back to our test. Yeah, we can do logs. Since there's an e, let's just add an ln on each side. The natural log of 1/2 equals a natural log and an e always cancel each other, so 2.5k. So if we divide by 2.5, we get 0.2773. K is a constant. It doesn't change. Once you have that, we now know our formula. So here's the formula to find our amount at any given point in time. What did it ask me to find?
How much of the substance will be present before?
So if I want the amount after 4 years, I can plug that in for my t. And I can just put all this in my calculator. So we would have 263.86 grams at that time. So for our formula to work, we had to know our y sub 0, our beginning amount, and our constant. So we use the set or the point given to find the constant, and then use that to find the amount after 4 years. Questions there? Let's try another one. That's our formula. What is my y sub 0?
600.
in order to find the amount after 6 years, I have to figure out what K is. So we need to find K. How will I do that? I know after 3 years, 300 grams remain, so I'm going to plug those in. So my Y is 300 equals 600 e to the K times 3. Divide over your 600. Then what do we do? The natural log and the e cancel, so the natural log of 1/2 equals 3K. Divide by 3. So my K is negative 0.2310. I'm getting a negative because this is decay. I have less as time goes on. All right, now we know K, so then we can go back and answer the question. It wanted to know how much would be present after 6 years. So you're going to plug that in for your T. So I get 150.04 grams, or if you said 150 grams. I'm pretty generous with the rounding on this one. All right. Are these okay? The other situations that we see this, interest is one. So at the beginning, I did put the 2 interest formulas, the continuous and the regular compounding interest. We can still use those. We've actually done some of these already. So how long will it take for the money in an account that's compounded continuously at 5.75% to double? If I say continuously, which formula are you using? Okay. We need to know what our variables are. The only thing I told you, 5.75%, so that would be the rate, but we always have to move it or put it in decimal form, so 0.0575. I'm trying to find how long, so I'm looking for my time. I didn't give you the A and the P. I just said I wanted to double. So let's just make up numbers. How much do you want to start with? 100. If I start with 100, then how much would I end with? 200, because I said I wanted it to double. All right, so then we could solve. 200 equals 100 E 0.0575T. So this is really just another exponential growth problem. If I divide by my 100, then what would you do? So the natural log of 2 equals, a natural log and an E cancel. We divide. So I get 12.055. It's in, time is always measured in years. So just over 12 years to double our investment. Any questions on those? I want you to take a minute and read the next problem and see if you can set it up. So let's take a look. How long will it take $1,000 invested at 2% interest compounded quarterly to grow to 2,700? So we are using the regular compound formula. What does the 1,000 represent? P. The 2% means R is 0.02. Compounded quarterly, what's that telling me? 4 times a year. And the 2,700 is my 2,700. We're looking for how long, so we're trying to find our time. All right, so we could divide by our 1,000. If you do 1 plus 0.02 divided by 4, what's that give you? To the 4t power. What would I have to do now? You can do ln, there's no real benefit here since we don't have e's. But remember, properties of logs, the exponent comes down in front. So then if I want to get it by itself, I just have to divide by the 4 and the log 1.005. I put that in. Hello. Okay, thank you. Bye. Quiet. Your homework is posted on Classroom. All right, so what did we get? I'm betting this is a parentheses. You didn't close that parentheses.
Right there.
Here's what I do that alpha by equals to. See it as a fraction. All right. Is that one okay? Last thing I want to look at is the change of base formula. So you need to fill this in on the front, I think, or did I put it in there already? I did, okay. So this allows you to change a log to any base that you want, so you could use your calculator. You know, if we think, if I said log base 2 of 27, okay, we don't know what that is. If I want to enter it into a calculator, the reason this works is if you do the definition. It's like saying 2 to the x power equals 27. If you wanted to solve for x, what would you do now? You would add a log on each side, and your exponent will come down. Divide that over, so it ends up being the log of 27 divided by the log of 2. So that's why this rule works. If we're doing change of base formula, it's so we can enter it into the calculator easily, so we'll always be changing just the regular log base 10. So it's just log of the argument divided by log of the base. And that's what we're doing every time. So on these, I would ask you to show the work, basically just writing what you're typing in your calculator before you do it. But math-wise, there's not a lot to do here. If I asked you to approximate this to 4 decimal places, you can do your change of base. It's log of the big number divided by log of the small number. Log of the argument over log of the base. So that's all the work I expect you to show, and then you just type it in. Log 7 divided by log 5. Would be 1.2091. So how would I set up B? So divided by log 2, and we get negative 3.321. Any issues with that? Oh. Do we need any more practice with this? You guys have a lot of time. I want you to try to get your homework done in class so you don't have to take anything home.